Good evening, everyone. Welcome to the 103rd lecture on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school, and my passion is teaching. So, the video series that you observe today is because of a consequence of a great alumni meet which I had with my students and my faculty members. And usually, the lecture series will have of three parts. Let me share my screen. Right. Okay. Right. And this is my website name or ID or URL or link. You can go through this to access all the videos that has been done so far, the 103 lectures. And this is my contact number. And if you have any questions in solving some physics problems, you can just message me your question, okay, with a brief solution of what you have received so far and why is this not a correct one, okay? Now, so far, we have been working on several chapters related to mechanics, and this chapter, there were several questions by several of the viewers, and we are currently working on forces. And the current topic of interest is understanding average force. So before I begin with my talk, let me just introduce us why am I doing something unconventional over here? While most of the lectures will be focused on either derivations or solving something like JE mains or advanced problems or problems from Irido and so on, which I am not doing it. The reason behind this is because it's a hobby of me wherein when I start grading the papers, I observe that some of the problems would be commonly a mistake would be seen in some of the papers. And most of the students do it. So let us say if there are 20 students in the class and out of which 18 of them commit a mistake, okay, in one particular problem, then I take up that particular problem and analyze why did the student make a mistake. Now, what would have happened is maybe the concept they have learned it correctly, but they had applied it in an incorrect context. So when we teach a concept, we of course teach the concept correctly, but we should also be able to tell them like under what context can you teach this and when you should not apply it. Okay, so this is something which is missing. So I felt, and as a result of it, so you can see these lectures so far 100 questions have already been passed. And now we are looking for some more questions. I think I have a collection of more than 300 numericals as such. And I think for the next 9 months or 10 months, I think I have sufficient amount of problems to work with. Okay, so now let me begin my topic on understanding average force. So you can visit my website to get all the videos which have been recorded so far. Now, this question is taken from H.C. Verma. There had been several copies of the same question being asked at several different places. Now, let me discuss this question first. A U-shaped smooth wire has a semicircular bending between A and B as shown. So, if you have an U-shaped wire, semicircular bending is there, which means what? So, this is only half a circle. This is half a circle. If this is my center O, so this is the radius R, this is also my radius R, this is also my radius R. Okay. A bead of mass m with uniform speed v through the wire enters a semicircular bend. It enters it like this and leaves at B. And leaves at B. It starts from here, it keeps on coming like this and leaves at B. And read the question once again. It bead of mass m moving with uniform speed v. That means the speed here is v. When it reaches here also it's v. When it reaches this point also v. When it exits also it's v. There's no change in the speed. That's what you mean by uniform speed. And leaves at B, the average force exerted by the bead on the part AB of the wire is. What is the average force? Now, out of 20 students, all the 20 have made a mistake. Now, why? What is the mistake? What is the student response over here? It says the bead is moving in a semicircular route. Okay, they are very much attached to the circular motion. It's attached to a semicircular route. The force that acts on the bead is nothing but your centripetal force, which is mv square by r, which acts like this, right? And since I have given you only this d here, this distance is d. D is nothing but your diameter. So therefore, I can now write d is equal to 2r. And what I need here is r here. M is given to you, V is given to you, right? I did not do anything here. I just need to substitute the value of r here. I need to say r is equal to d by 2. I'll substitute it here. And as a result of it, I get the answer as 2mv square divided by d. Okay. 99% of the students had made the mistake. Now, what is the problem in this? Circular motion. When it is a circular motion, you should find out the force. What force is present acting on the particle? Centripetal force, right? So the context is circular motion. While the way how you have applied, okay, depends. Now, let us read the question once again. What is the question asked here? Find out the average force. Now, when I say centripetal force, where is the force acting? The force is acting here. The moment it enters into a circular path, it is acting here. How is it acting? It's acting like this. It's acting here. It's acting here. It's acting here. Everywhere it is acting like this. Now, what do you mean by average? Is average equal to the force acting here, and so on? No. So that's not average. Now, how do you find average? Average is a function of all these forces acting in several directions. Will that be zero? No, it can't be zero. It cannot be zero. Some of these forces, I should take the components of this. If I'm doing it conventionally, I should take the components of it and then add up each one of them and get the answer. Okay, very difficult to do it. And moreover, we can also say, yeah, so this is one method which you can do. Now, let us look at the correct solution. Okay, how to arrive it. So definitely, this is an incorrect one because the force that I have described here is nothing but the instantaneous force that acts at every point, right? Now, let us look at what you mean by average. How do you find the average? If you recall the average velocity, how did you determine the average velocity? You took the total displacement divided by total time taken. And thus you got the average velocity. You never ask what is the velocity at every point over here, right? So in a similar way, when it's average speed, also you do the same thing. Now, in a similar way, when we talk about the average force is nothing but mass into acceleration average. Right? Because mass cannot be averaged. The same mass is present. We cannot average the mass over here. Now, what I can do is, I can still write this as dp divided by dt of average. Can I write like this? Right? dp by dt is nothing but force. Okay. Or I can also say delta p average by delta t. Delta p, for those who are not conversant with calculus, let me write like this. Delta p average by delta t. What is delta p? Change in momentum. Right? Change in momentum. Now, what is this? Now, let me write it once again. I'll write this as m times v final minus m times v initial divided by the time taken for it to go around the circle. Now, is the time given here? Time is not given here. Okay, let it be. We'll calculate time later on. Okay. So now, what's happening here? MVF. What is MVF? MVF is acting like this, right? VF is nothing but the velocity which is acting in this direction. V final, the direction of velocity is like this over here. What is initial velocity? Initial velocity is at this point. This is my initial velocity, which is Vi over here. Now, look at this. If I assume this is my positive y-axis, this is my positive x-axis, then can I say that this direction is positive Vf and this direction is negative Vi? Right? Obviously. So I can now write this as m times Vf minus m times, see this Vi is now negative because it's moving along the negative x-axis. So I will write this minus Vi because all these are vectors here, right? I cannot just substitute like that. Divided by time taken. In other words, now what I will do is I'll write this as, now what is Vf? Vf is V, velocity here. What is Vi? Vi is also V. So therefore this becomes m times Vf plus m times Vi, which is nothing but 2 times mv divided by time taken. Are you getting me? Okay. So why is it 2 times mv divided by time taken? Because we know that Vf is equal to Vi is equal to V. Okay. So as a result of it, I substitute it and finally I get the answers 2mv divided by time taken. This is your average force. But now you have a time here. Somehow you have to eliminate this time. Now, how do you eliminate it? Now, again read the question. In circular motion, finding time is quite easier. How? I don't have space. I will write it over here. I will write here. Now, time taken. Now, we know if the particle completes one full circle like this, okay, then the total distance is nothing but 2 pi r. 2 pi r. Okay. And total distance divided by total time taken is nothing but speed. Why speed? Because the average speed. See, it's uniform speed here, not velocity. Okay, I can write like this. So in other words, now I can now write, what do I need here? I need time here. Okay, so time t, see this t and this capital T are different. I'll tell you why it's different. What is this capital T? Capital T is the total time taken by the particle to start from here, go through one semicircular arc, then complete one more semicircular arc. Unfortunately, you don't have this one more semicircular arc. You only have half of this, right? So now how do you relate this T here? So the time taken to go downward plus the time taken to go upward, okay, is equal to capital T. Now, what do we have here? We have only small t. What is a small t? Small t here is nothing but capital T divided by 2. Do you agree? Okay. It takes, let us say, for example, it takes 5 seconds to start from here and to reach here. The same 5 seconds would be taken if it wants to go upwards also. Okay. Neglect gravity. I'm not bringing into gravity here. So therefore, it takes the same time to reach here. This t equal to t by 2. Now, what I have is that from this equation, okay, let us forget this. Let us write from here. T should now be equal to 2 pi r divided by v. So I push this t on the upper side and pull this v downwards. So I get this expression. And thus what I will do is I'll substitute for t here and I'll get the answer as 2 pi r divided by v divided by 2, which should now be equal to pi r by v. Right? We got an expression for t. And that too in terms of r and v. Now let us substitute it. So we should now be equal to 2mv. I am substituting this t equal to pi r divided by v, pi r divided by v in this expression. Let me put an arrow. Put an arrow. Okay. So 2mv divided by pi r divided by v, which should now be equal to 2mv square divided by pi r. Right? Wow. See how nicely we have got a solution for this. Is it not? Okay. So physics is always easier. Right? Only thing is we people make it complicated. So we should know like how to proceed further. And that proceeding comes only step by step. When you start thinking and we know properly how to proceed further, we'll be able to easily achieve or easily able to solve the problems. Okay, that's all about this problem. Thank you, friends, for taking time and watching my video. So be logged in for more updates. Do like, share, and subscribe to my channel for more updates. And this will also be an appreciation to me if you start sharing with your colleagues, your friends, your classmates, and so on. Thank you. Thank you once again.